So here's an example of how to find the sample size in section 7.2. So in section 7.2, at the end, you will be determining sample sizes. So let's look at number 34. It reads, in dataset 1 in Appendix B, it includes the pulse rates of 147 randomly selected adult females, and those pulse rates vary from a low of 36 beats per minute to a high of 104. Find the minimum sample size required to estimate the mean pulse rate of all adult females. And so what we want to remember is we're asking to find the sample size. So because it's a sample size and not a confidence interval, I'm going to go to a sample size led formula, an n equals formula. It's to estimate the mean, right? Find the minimum sample size required to estimate the mean pulse rate. And so I'm not going to use the one with P's and Q's in it. I'm going to use the one that's context appropriate, and it's going to be this formula right here. So look at what we can fill in right now. We have been given a level of confidence, which always helps us find the z off over 2. It's 99% confidence, so you may remember that that's 2.575. If you've forgotten, you can go to your z chart at the bottom right hand corner. It will tell you that 99% confidence is associated with 2.575. On the bottom is the error, and they tell us that we want to be within 2 beats per minute. So they're allowing a 2 beat per minute margin of error. So 2 just goes down there. So the only thing left for us to find is this sigma area. Well, we know how to get sigma. If we're not given it directly, and as we read through that problem, they never ever mention a standard deviation. So we have to go through the range rule of thumb. So ideally we know what the range of pulse rates are, and we do. We know it ranges from a high of 104 to a low of 36, and we're going to divide that by 4. So we're going to take the range 104 minus 36, and we're going to divide that by 4, and we're going to come up with 17. So 17 is what goes into this area right here. So we have to do that side work. Now, one thing I want to make sure you don't forget is to square it. So I kind of held off putting that square. It might have drove some of you nuts, but there's that square. So I have seen it where the answer comes in not as large as it could be because somebody forgets to square. So 2.575 times 17 divided by 2 is going to give us a number, but we're going to immediately square that number, and we're looking at this. 479.06, and it keeps going. So I can't give you full credit for 479.06. 479 would be wrong because it's not big enough. It's got to be a sample size, which has to be an integer. And so my choices are limited. It's only 480 would be the minimum sample size required. Now, if you noticed in that problem, I didn't type it out. There's a part B. And part B says, hey, do the same thing, but this time assume sigma. And actually, let me throw that word in there. They want us to assume sigma is equal to 12.5 beats per minute. Now, where they're getting that from, they describe it. They're saying that was a sample standard deviation for the 147 women. It's not the population one, but let's use it, is what they're saying in part B. And so as we go to do the same problem, they still want to be 99% confident, so it's still 2.575. They still want to be within 2, and we're still going to need to square it. But the thing that changed is they gave me a standard deviation to plug in, so I don't have to do this side work that we were doing up here, right, when we were calculating sigma, or at least a representative of it. I can just drop in the given 12.5. And they just want us to see how the numbers change. So if I take my 2.575 times 12.5, divide that by 2, and square that, let's see the difference in the numbers. 259, and this is a great number to see together, 0.008, and then it keeps going. Don't answer 259 because it's too small. It's got to be 259 and some change to work. So I call it, again, the don't be lazy principle. Go talk to 260. Go take a sample of 260 adult females, and you'll be within 2 beats per minute of the actual value. Now the 480 was if you didn't have any background information. So the 480 is going to be a very safe number to do. But if you wanted to cut that down, you could use what happened in a prior study. So C just has you compare those results.